welcome to this today's workshop. Is a very short introduction to this topic on data visualization. My name is Chong. I'm actually a lecturer from College East. So wanted to share this data visualization topic and also a very nice free tool called Tableau to let you all try out and get the hang of this data visualization. First of all, let's take a look at this short GIF over here. So are you all able to guess what is this visualization about?
Yes, it's about a hurricane because I can see the swirling. I see the black and white swirls.
Okay,
I think
thanks.
it suggests that it could be something like a tornado, but it's more of a hurricane.
Yes, you're right. So in fact, this is a tornado typhoon. Okay, hurricane only exists in the northern American hemisphere lah. Okay, in the near the equator or the southern region, we call it typhoon. So this is actually a typhoon Mangkut back in 2018. I think when you were around Sec 2 or Sec 1. Okay, so in 2018, Typhoon Mangkut actually came over. Is actually a Cat 5 typhoon. So you can actually see part of the map of Philippines on the left side of the screen. So this is Manila, and this is the northern part, Baguio City, on the northern part of Manila. Okay, so what happens is the Mangkut actually hit Manila and the northern part of Philippines, causing extensive damages, flooding, and so on. So this is a visualization graphic of the extent of this Typhoon Mangkut as it approached Manila and pick up speed. The different color of the typhoon actually represents the speed or the velocity of the winds. So if you can see, while the typhoon is spinning anti-clockwise, right, the center of the typhoon, which is the eye, right, actually has a blank area, which is the eye lah. So typically the eye is the area where that is the most common. That's why you don't see any color. The blue is actually the color of the ocean underneath. But beyond the eye of the typhoon, right, you see a lot of different colors like gray or white. So that represents the high speed of the typhoon. Towards the other outside area of the typhoon, you see the color gradually change into reddish or yellowish. So that set means the darker the color or the closer towards the black spectrum is stronger the wind. So that's how the meteorologists or the climate guys actually estimate the extent of the damage of the typhoon. And hopefully before the typhoon hit any country, they can actually know how many people they need to clear. Okay, because this concerns lives. So that's why by looking at the color, they know how fast is the typhoon, and they also know the extent of the damage, which city are affected, and they have to evacuate how many people and so on. So this is a very true useful use of the data visualization, because it helps scientists to actually visualize the data, which we normally don't see in a graphical format. Okay, so that said, actually we wanted to tell you this thing about data. So in data visualization, it starts with this idea of data storytelling. So every data has a story. So by looking at the data, we can actually interpret the story underneath the information, the data. And of course, we will talk about what is visualization, data visualization. After that, the second half of today's session, we'll talk about the use of Tableau, the free software, specifically some labs or topics that we are going to cover if time permits. Okay, how we can use Tableau to create some very simple visualizations. Okay, every data has a story. Depending on what data we want to interpret, we can use different kinds of so-called charts or different visualization to represent the information. Okay, it can be a bar chart, it can be a pie chart or a line graph and so on. Okay, so in order to tell the story behind the data, basically we try to stick to the 6 principles of communicating the data. First of all, we need to know our goal. What do we want to achieve from this data visualization? What is the story we want to tell? Next, we want to use the correct data. Okay, because if you are aware right now, especially during the COVID pandemic, there's a lot of fake data information that is available online. So some of these data are not true. So if we use the wrong data, we will actually get the wrong result. Okay. Also select the suitable visualization. What is the most suitable visualization to tell the user? Design for aesthetic. This is more like how to make the visualization more appealing to the eye. Choose an effective medium. How do we want to channel the information? Social media or on the printed newspaper and so on. And finally, verify the results. So first of all, for knowing the goal, we want to know who are the people we want to tell the story. So assuming if let's say you are a newspaper journalist, so who are the target audience? Are they the older senior folks who stays at home, or are they the younger generation who use Instagram or social media and so on? And what do we want to achieve by telling people? Is it to inform them about this information, or what do we want to intend to mean? Okay, do we want to get them to know more or be more informed or need to take action and so on? Okay, so example over here is this. So this is visualization data of this. Okay, if you watch soccer in the past, Barcelona on the left and Real Madrid on the right. So the idea set is this. So if you guys are a soccer fan, you probably have known that Barcelona is a team from Spain, and they actually play what we call a passing football. So what happens is typically when they want to score a goal, they have to pass between the different players, pass. After passing so many players, then finally somebody in front, the striker will try to score the goal. Okay, so for the case of Real Madrid, it's quite straightforward. Okay, whoever got the ball, pass to the striker in front. In that time, it was Ronaldo lah. So he'll just score the goal. So it's very straightforward. So what we are trying to tell you is, in data storytelling, we want to go straight to the point. Okay, because most of us are very busy people, so we don't want to listen to long grandmother stories. We want the information straight. So when we want to show the information, let's say on the social media or on the internet, right, we do not want the information to be too naggy. We want it straight to the point. So this is one example, or one of the intent of storytelling. Tell the information straight so that the user can know the message behind the story. Okay, so sometimes less is more. Okay, by trying to explain more, you actually make the information more complicated. Okay, so use the right data. Sometimes if you use the wrong data, you may actually complicate the message. Okay, next we talk about suitable visualization. So it depends on what kind of data you are using. Okay, so in a typical scenario, we have data, for example, like numerical data. So in this case, we can have data such as coordinates, or data such as, for example, the temperature, or in current context, during the pandemic, we have the number of cases in the community, the number of cases who have vaccinated or unvaccinated, and so on. So those are what we call quantitative data. Okay, for the other kind of data like ordinal data, basically these are arranged in order. So like for example, we have data such as small, medium, and large, or first place, second place, third place, and so on. Or whether you agree or neutral or disagree. So all these data are what we call ordinal, because they are not measurable by numbers, but they can be arranged in a particular order. Then of course we also have what we call the nominal data. So nominal data refers to, like for example, data which we can arrange in particular groups. So say for example, you have data such as cat, dog, and horse. So these are data where you can group them in an array of animals, or let's say cash, credit, debit are talking about information relating to finance. Okay, so these are what we call nominal groups of data. So depending on different kind of data, you might have to use different kind of charts or visualization. And also, we have to watch out for design for aesthetic. Okay, it's a very broad topic, but basically you can broadly see some of these things like poor color schemes, fonts are distracting, different kinds of fonts, and so on. So these are more like how you lay out the data or the charts. Okay, if you use the wrong kind of color or the wrong kind of font, it can give the user a different kind of feeling. Okay, say for example over here, these are two different charts of the same data. Okay, on the left hand side, you have the data for this chest position. Okay, so over here they actually have the two axes, the vertical possible position axis, and the right, which is not very clearly specified over here. On the right hand side, you have a better design data story where you have the dots that are spread over, and the left hand side, the vertical column is written in a clear numerical form. Okay, compared to the version A on the left, all the numbers or zeros are actually squished together. And on the right, you can see that the zeros are spread out with the comma in between every three zeros. So this can actually give the user a better viewing experience, because on the one glance, you can see that the right chart, version B, is a better chart because it's more straightforward. People can see it more nicely, be it the axis name and how you actually draw the charts, and also the explanation of the description of this chart on the top. So these are some of those small little details which can actually make the difference between a good data story or a poor chart that you see on the left. Also another case where sometimes, depending on how we actually lay out the information, it can appeal to the user, or even it can give the wrong information. So on the two charts here, it actually shows the number of Apple employees for the years from 1994 to 2011. So on the chart on the left, basically it shows the bar chart on the number of packs, number of employees, at different stages of the company, the Apple's company's history. Whereas on the right hand side, you can see that the same chart, but this time round is more informative, because we can see on, for example, the vertical axis, there is a title of the vertical axis, total number of employees. So we know that 70K actually stands for number of employees. And also in between each key stages of the company history, there is a small informative icon where you can actually visualize the progression of the Apple's history through the Apple's product release. Okay, because these key dates like 2001 is actually the date for the iPod launch. The 2007 is the date for the iPhone, the first iPhone, and 2010 is the date for the first iPad. So using short infographics like this can actually make a lot of difference to the infographics and make your story more appealing. Also, instead of trying to squeeze all the years on the horizontal axis, you can actually highlight only the key dates or the key years on the horizontal axis. So it makes the whole design more simplified instead of trying to compress so much information in a short axis over here. Okay, also when we talk about storytelling, we look at the different mediums, what we want to channel the information. So it depends on the media. If you are using a newspaper, it is static info. So you will be able to show live information like the typhoon Mangkut you see just now. Okay, so in animated info like the GIFs, you can't show on newspaper. So those are static media. Okay, and as the variation progress, you can be from the animated interactive into a more combined experience where in person can be like, for example, the news or the information which you deliver through the VR platform. Okay, so there are some websites that can actually show the video of the person in a 3D, and you can experience it in a 3D in-person view. Okay, so those are the more complex kind of medium where you can share the information. Finally, once you share the information, it's important to check with your audience whether they have received your message or not. Okay, and also it's important to check with the audience, did they interpret the message correctly? Okay, because sometimes you want to deliver the message but end up the audience will interpret the message in a different way. So it's a cup half full or the cup half empty story. And also audience, are they able to react in the way you want them to react? So these are the three things that we have to consider when we actually release the data story and check on the results. And finally, of course, how we check, basically we look at the three possibilities through different types of analytics. So broadly speaking, we can analyze the data or information using the descriptive or the predictive or the prescriptive analytics. So broadly speaking, this is what it means. So for descriptive analytics, it means you want to analyze what happened. Okay, what is the cause behind this the information and so on. Okay, for predictive analytics, so we want to predict. So for example, what will happen in the near future or in a few months or a few years later, what will happen in the future. And finally, for prescriptive analytics, we will want to consider like if we want to make it happen, so what should we do? How can we make it happen? So these are the three kinds of analytics that data analysts will examine when they try to look at the data and try to interpret and give the user, the reader, the information according to these three analytical description. So, okay, I think this is a chart that we actually try to explain this whole story. So as mentioned just now, we have different kinds of data, what we call the structured data and the unstructured data. Okay. Also, we can split the data by the analysis through user-driven or the system-driven analysis. So for structured data, we normally talk about data that have a particular format or structure. Like for example, let's say for COVID cases, how many cases are vaccinated, or how many are of a particular age group, or of the COVID cases, how many of them are of a particular gender, or of a particular race, or so on. So those are what we call structured data, because we can actually structure or arrange the data in a particular format. For the case of unstructured data, these are actually more kind of data or randomized data which do not follow a particular format or structure. So like for example, sentiment analysis, that means let's say when we visit, let's say Alibaba or Shopee, when they actually propose a product, or they want to tell us, hey, there's a new offer. So what is the kind of offer they want to give to the user? Okay. It depends on the user's previous purchases and which website or which product they view. So it also depends on what kind of web pages the user visit, and what is the text they actually search for inside Shopee or inside Lazada. So those are information that are unstructured. So it does not follow any particular structure. So these are how we broadly classify the two kinds of data. And depending on the different kinds of data, we can use different kinds of tools. So you can also see that Microsoft Excel is a very good tool for structured data, and driven by the user, because users like us, we can use Excel to create a worksheet to display table information and so on. For the other more complex data, or where we have to analyze more complicated stuff like language or behavior, we tend to use other softwares like IBM or some other semantic engines and so on. Okay, so structured data, as mentioned, is a rigid format depending on the how we process it. So these are typical data, like for example, in financial system, in the banks, we have all the transaction data that you want to share in the spreadsheet and so on. Okay, so these are some examples of unstructured data, as mentioned before. So data that do not follow any particular pattern, like sensors. Okay, you use the trace together Bluetooth sensor. So all those data are unstructured, because there is no particular way to predict, like when what is the data for the next sensor. Are you going to be near this COVID positive guy or not? Okay. Also audio files, like for example, we are recording this this video session. So all these video audio files are also unstructured, because there's no way to predict or how to classify what is the kind of speech, or what is the kind of screen that we want to show in the video audio files. Okay, so generally for the case of unstructured data, we can see that over the years, we are progressing more onto complex unstructured data, more due to the proliferation of social media and the internet. So just before the internet was exploded in the 2000, okay, most of the data are actually relational. That means all the bank data and all those stuff. But as we progress on into social media and internet, we have a lot more unstructured data, like messages, images, videos that we share on the different social media. So we tend to see more unstructured data nowadays. Okay, so these are basically the main objective that we want to achieve when we do the visualization, to explain data, to solve the problem, explore data for better understanding, to highlight invisible information in the data, and to predict the data trends. Okay, so let's say, for example, or in this case of Facebook, there is a chart. On the left-hand side, the chart in blue for the males, and the right-hand side, the chart for females. So in one glance, we can see that the main bulk of the user for the Facebook are actually classified between 18 to 25 years old. And also on one glance, we can also see that for the older age group, that means from 35 to 65 ages, we see that there are more female users for Facebook compared to the male users. So with a very effective chart visualization like this, we can see at one glance many info, more females for the older generation, and also the main age group is 18 to 25 and so on. So this is how effective visualization, a useful visualization can be. Another way, let's say for example of a good visualization is like this case of a chart on the overdose situation of heroin in the U.S. city of Cincinnati. So sometimes the chart can also be used to identify areas of concerns. So in this case, the charts over here highlighted the number of cases that are reported in the city of Cincinnati, and where are the cases of the heroin abuse overdoses that are reported. And we can see these are the regions highlighted by the dots over here. So if the city planner for this Cincinnati city, they can actually look at the distribution of the circles, and they can actually try to identify the areas or the zones where there are more heroin overdoses, and maybe try to put more healthcare or counseling centers near that region. Okay, so this is very useful for cases of healthcare planning where they want to highlight the distribution of the resources. Okay, you also see this kind of charts now, especially when we plan for COVID vaccination. They want to look at the distribution of the number of cases around the country, and how they want to isolate the distribution of the cases and so on. Okay, this is another way that you can highlight the same information that you saw just now. So previously on the previous chart, we show the information on the geographical format for the heroin overdose. We can also look at the data on another format, which is what we call the time format. So in this case, the same data is examined in terms of time. And instead of looking at the geography location, the time gave us another perspective of this data so that we can understand when or at which particular time do the particular heroin overdose occur. So as you can see over here, between the timing from 12 a.m. to maybe 9 a.m. Is understandably low of heroin overdose cases because most of the people in the US are sleeping. And we also see that gradually as time progresses from 10 a.m. to 11 a.m., we start to see darker colors or the number of heroin cases increases. Okay, so these are key important information because it shows that the people are more active in this particular timing. Okay, between 2 to 3, 2 to 4 p.m., there is a huge increase in the number of heroin overdose cases and so on. So by planning all these timing information, right, planners can actually predict or can try to plan for the resources that hey, maybe between the afternoons 2 p.m. to probably 7 p.m., there will be more emergency cases of heroin overdoses. So maybe the ambulances or the health responders have to be more alert between this timing from 2 p.m. to 8 p.m. and so on. Also, sometimes when we look at the data information, we have to be very careful about what we call invisible data or outliers. So in this case, this is an example of a temperature measurement across this maybe 12 periods throughout the days or years. Okay, so what happened is we can see that the numbers are pretty consistent from 70 plus Fahrenheit until we come to this particular number, object 10, suddenly the temperature increases to 300 Fahrenheit. And after that, 11 and 12, it drops back to 70 plus again. So this is what we call an outlier. So outlier in the data analysis context means data that is special or that is not in line with the trend. Okay, so the trend over here is all 70 plus Fahrenheit, but this 300 Fahrenheit is a special case. So when we analyze data such as this, we have to think about, do we want to include this data? Because data like this can affect the general average or the trend of the whole measurement. So you may want to consider removing this data or ignore this data because this could be a wrong measurement. It can be due to, let's say, the thermometer is not functioning well, or maybe the user misread the information on the thermometer and so on. Okay, so outliers like this, we have to be careful. Okay, and as a planner, we can also use a visualization like this to predict potential trends and statistics lah. So over here on the right, you have the charts of the population projection for India and China. So as you can see over here, China on the left in red and pink, and India on the right, this onion orange and yellow. So as the number of years goes by, we can see that the top half of the charts, that means the older generation gets fewer and fewer, which is normal because people will pass away from illness or old age. And what is interesting is this, we can see that over here, the China population is actually decreasing as the years goes by. Okay, you can see that the projection between 1990s to 2000s to 2030s, we can see that the population is actually decreasing. And the large number of majority of population is actually growing older. Okay, so this is useful information for city planners in China. So that is also one reason why China is actually scrapping the one child or two child. Now they call it the three-child policy because their population size is shrinking. Okay, it will affect their future growth economy because fewer and fewer young people, just like in Singapore, there will be fewer and fewer younger people like you, and there will be more older people. That means younger people will have to support more older people in the future. So there will be a stress on the economy. On the other hand, on the right, India, we can see that is pretty much consistent. So the population growth is consistently large, and there isn't any reduction in population predicted for the next 20 or 30 years because India is going to be growing as the older people gets older, the younger people will be getting more and more. So you can see that the shape of this population growth like an onion, it doesn't reduce compared to China. So this kind of visualization is useful because city planners or the population growth, can actually predict, and they can actually plan ahead of the country's budget and all the healthcare planning and so on. Okay, visualization tools we commonly use so far. Excel is a very well-known tool from Microsoft. Other visualization tools we also use are SAS, IBM SPSS, and Tableau. Okay, so comparing between Tableau and Excel, Tableau is essentially to visualize the data. Excel is more for organizing the information or data and to try and calculate the data using formulas. Tableau is very user-friendly. Later you will see. It's drag and drop, not much typing involved. Quick visualization. For Excel, you have to understand the data and you have to manipulate the columns and rows and so on. You allow in real-time interaction data with Tableau. Excel also allows real-time, but you have to install external apps. Tableau, no coding. You don't really need to know any coding. For Excel, you need to know how to do what we call Visual Basic Scripting, VBA scripting, or macros. So Tableau is very commonly used by data scientists and data analysts. Excel also by data analysts and more for programmers and developers. Tableau, because it's very user-friendly, not much coding involved, is very useful or easily used by business people as well, where they want to track businesses and the key performance indicators. Excel is more for calculating the data transformation and so on. And finally, Tableau is useful because it can handle very large volume of data, or what we call big data. Excel, yes, you can also handle large volume of data, but the original intent of Excel is designed for small volumes of data in megabytes. If your data is too large in gigabyte, then Excel will not be able to handle it. So there are few flavors of Tableau, which you can actually see on the internet. Tableau Desktop, Tableau Prep, Online Server, and Public. So for our practice, we are using Tableau Public, which is a free software. Okay, so some files that we can actually use in Tableau, like Excel, we can use Excel spreadsheets. We can also import data from the SQL databases, Oracle database. We can import Hadoop, which is actually a big data technology, and also cloud data from Google Analytics or Salesforce or Microsoft Azure and so on. So it's a very flexible tool. User interface, later you will see, is quite straightforward. You can actually simply select the different charts and drag and drop and produce the chart straight away. Okay, so there are some free data samples which we will explore later on. For example, our SG data bank, data.gov.sg, also public transport data bank like mytransport.sg and so on. Okay, some references you can look forward, or the content of this workshop is actually taken from this stuff over here.